So, we will see in this class the next generation power sources, which are known as electronically regulated electronic control power sources, right. So, there are again 4 or 5 types which are commonly used for GMAW, GTAW, SMAW. We will look at them one by one. Okay. So, the first development that actually happened in electronic power regulator system is SCR phase control systems. So, what are these SCR is silicon control rectifier. Okay. So, these are semiconductor rectifiers, and by using these SCRs in sequence, we can also increase the efficiency of the power transmission from the mains to the power source. Because if you remember in previous cases, 3-phase power, unless you have a proper rectifiers, transformers as well, you most likely will be wasting the other 2 phases. You will be using single phase only out of 3 phases, right. If you do not have a proper transformer setup, so you need to have 3 phases, 3 transformers and rectifier systems, so that each phase can be regulated. But even then you cannot really use those 3 phase outputs to a single phase the arc voltage. Okay. So, we can change that by using a circuit where 3 phases that are coming from the main can be very effectively used by placing silicon control rectifiers in series, and these 3 phase main currents can be converted into required low voltage high current arc. Okay. So, we will see one by one. This is the first development happened from the conventional to the electronic power regulator systems after the semiconductors arrived. Okay. The silicon control rectifier phase control power sources. And then a lot of development happened in transistor technology. Okay. Transistors, they came into picture, and then these transistors can be very effectively used to regulate the electric current. Okay. So, then we started using transistors as well. So, we will see some of the power sources which actually uses transistors to regulate the output current, and you can also rectify, you can also invert the output current. So, they can be used if you are using it in a series number of transistors. And then there are improvements in terms of the switching on and off of transistors. So, then the transistor capacities are also increased in terms of on and off the output characteristics. So, from the conventional transistor to we went to secondary switch transistor power supplies. And then finally, the state of the art is the primary rectifier inverter systems. And if you look at nowadays the welding power sources, you can lift. Okay. It is like very compact, very tiny, is not it? So, sort of in a small box. But if you look at the moving ion the power control power sources, can you lift? It is not possible. It's so huge. Okay. Even these the SCR transistor, the primary switch transformer supply, they are also relatively big in size. But if you look at the modern power sources which are rectifier inverter based systems, it is extremely compact, is not it? So, we did one trick, very simple trick. With that, we could reduce the size of the power source and the cooling requirement tremendously low. So, we look at what modification made in terms of these circuits. So, power source suddenly became very compact. Okay. So, of course, we also use the microprocessor semiconductor transistor inside, but by changing the circuit components, we made the power sources into very compact systems by using the inverter based power sources. Okay. And then we also have hybrid designs with the microprocessors. We will also see end of the class. So, how we can use the microprocessor computer programs, inbuilt feedback control to regulate the current and voltage in the welding, right. So, first one, SCR systems. Okay. So, SCR systems, as I said, it uses silicon control rectifiers. So, these are the A, B, C, D, E, F, these guys. So, if you look at the main inputs, 3-phase main coming to main transformer. So, main transformer actually transforms from primary to secondary winding, and secondary winding is connected to, so in this case 6 SCRs, okay, so 3 in one phase and the other. And if you look at each line is connected to one rectifier series, SCR series, isn't it? So, the one phase and the second phase and third phase. So, advantage over here is, so now by switching back and forth these rectifiers sequentially, and we can regulate the output current. You can also convert into DC. For example, if you carefully control the output characteristics, suppose if you want to have a DC current, so you have an off cycle which are coming from ABC only going to the output cycle, okay, so then you will have a DC, isn't it? So, if you have if you want to regulate, if you want to reduce the amperage, for example, you can only turn on A and B, and you can turn off B and C and D and F, E and F, right. So, based on the sequence of switching back and forth the rectifiers SCRs, okay, we can regulate and convert the whatever current comes in to either DC or AC with step down amperage, right. So, these are possible because of these SCRs. In diode based systems, the response time of diode is very slow. So, we cannot regulate the diode based rectifiers as we need in this case, because it has to happen much fast quickly, right. So, the A and B, C, the rectifiers which are connected to mains, by carefully switching back and forth, we can either have a DC current going out of these SCRs or AC current, whether it is in a high power or low high amperage, low amperage, we can play around. So, I am just giving an example. If you have an SCR power source, you will have thousands of SCRs in the circuit, okay. So, if you look at the circuit board, see, so these are simple circuit boards, right. So, you will have an SCRs embedded in a circuit board, and which can regulate the output current, whether it is AC or DC based on your need, and the circuits, these rectifiers will be turned on, okay. Obviously, then you can also have a smoothing inductors, and then you have an additional regulators to regulate the current which is coming from these SCR guys, which will be sent to the arc. Yes, it is clear. So, in this case you still have a transformer, but these SCR guys would regulate the output current from this main transformer. It is efficient LED, okay. So, because we have 3 mains, 3 phases all connected in series with these rectifiers, and then we can convert the transformer high voltage current into low voltage high amperage current, which are needed for the welding applications. So, you can make it as an AC current or DC current, how you are switching back and forth to the rectifiers SCRs, and you can also step down by turning these rectifiers based on the output need. Yes, it is clear. It is very simple, right. And if you look at the board, it is also very simple. So, you will have an rectifier SCRs and the inductors systems. How many of you seen a motherboard of a computer? What are they inside? Do you have similar system? Isn't it? Capacitors, for example, inductors, okay. Then you will have diodes sometimes, and what are they used? The same purpose, regulate the output. In some cases, if you want to an USB port, so then you need something to reduce the high voltage into low voltage, isn't it? So, how is it achieved? The same way I am explaining here, isn't it? It is the same way. So, it is not complex, it is used in everyday life, regular life, okay. So, based on your needs, in a computer motherboard also you will have all these things. You will have rectifiers, diodes, inverters, inductors, capacitors, because each input, for example keyboard, would need a certain voltage to be operating to receive the inputs. USB port needs a defined voltage. So how do you supply these voltages to these the input modules of computer? By having all these things. Okay. So one thing is in this case we have a very high amperage. In our computer system, your low voltage is also low, amperage is also reasonably low, right. So that is what, if you look at a motherboard, you see all these things, SCRs will be there, diodes will be there, okay, the inductors will be there, capacitors will be there to regulate the output. So processor may need a certain voltage to operate. How do you supply that voltage? Right. So you need to have a defined circuit to supply required current power, voltage power to this processor, right. Same thing is power source as well. One thing is how you achieve, how efficient the circuit. It is determined by what are the components are there in the circuit. So the power source is nothing different. If you open the power source, you will also have the boards in any equipment for that matter. These boards contain all these, right, to define, to give the defined the current and voltage needed for the operations. Okay, so in unfortunately in our case we also need a low voltage high current arc. So we need to define the circuit, and the efficiency is determined by the what are the components what you have. So already compared to the moving iron power source, the SCR phase control power source much more efficient. So because the heat loss, the efficiency is much higher by using the SCRs in the circuit, right. So we also use all the three phases coming from the main to regulate the outputs. Yes, it's clear, it is nothing strange, it is the same what you have it in the computers. Okay, so this is clear, right, the SCR phase control circuit. Good. So the second one again, so the other difficulty with the SCR is the switching time. The rectifier, they have their own response time. Okay, suppose if you want to do a rapid response, so I want to generate current output with a pulse of 50 hertz, right. So then you will have to, the rectifiers would work, but response time of SCR is also not as good as what you want. Okay, so semiconductors, they also have their own response time. Diodes are even worst getting responses. Even the semiconductor rectifiers also is not that efficient. So then transistors can be used. So a transistor if you use, it is very simple, the circuit becomes extremely simple. You do not need rectifiers, you do not need any inductors, because transistor would do the job for you. Okay. So in this case, so you will have a primary transformer rectifier system, so which would convert from main to the circuit of the power source. You will have a transformer, and you may have a rectifier to convert the current, high voltage current coming from the secondary winding into high voltage DC. So now we will have one transistor or transistors. I am giving one example of transistor. So in this transistor can be made into operational by giving an input current, input voltage. Okay. Suppose again the same as the magnetic amplifier we use. So this transistor has a defined the power rating 0 to 10 volts for example. If you give 10 volts, it shuts off. Okay. And if you have 9.5, it will release the output current and voltage based on the transistor power rating. Okay. So by carefully manipulating the input voltage to this transistor, we can regulate the output, that is it, right. This is clear. So we generally need, what you need is in simple electronic control, which controls the the transistor output characteristics. Now the system is already becoming smaller, isn't it? In the previous case you had rectifiers, silicon semiconductors, inductors. After the arrival of transistor, you still have the big transformer part, rectifier part over here, but the output circuit is all transistor based. The output from the transistor can be regulated, and you give an input from the rectifier or transformer directly, and the output can be regulated by the electronic control of the transistor. Yes, it is clear. So, disadvantage of this is the transistor should be cooled efficiently. For example, you send a current of 100 amperes with a voltage of whatever, so from the main 230 volts, and you want an output of 10 volts and 50 amperes. So, remaining, where does it go? Okay. So, it has to be dissipated by the transistor, is not it? So, the transistor should be cooled very efficiently, because transistor, the arrest steps down the current and voltages and sends the output. That means the remaining should be dissipated as a heat, is not it? So, then the cooling requirement of transistor is enormous, especially if your transformer the characteristics and such that. So, you need to have an efficient cooling for the transformer to cool, so that the transformer can regulate the current outputs very effectively. Yes, it is clear. So, these transistor based systems are very efficient because it becomes lighter, the compact, and you can also regulate the output from the transistor using an input. So, that will control the transistors, the output characteristics. The main negative point is the cooling, right. So, you need enormous amount of cooling to regulate the temperature of the transistors. So, in order to avoid this problem, okay, after development and after we have much more development in transistor based systems, so we started using the switching transistors. So, in the switching transistors we do not need a regulator input signal transistor to get the output. So, in this case we switch on and off the transistors and extremely fast rating. Okay. So, transistor is continuously switched on and off. Okay. So, in this case, suppose if you want to regulate the output control, so you can change the frequency of switching on and off, so that the transistors output can be regulated, and you can also generate an AC waveform based on the frequency of the transistor operations, and then you can also regulate the outputs by rapidly switching on and off the transistor which is there in the output circuit. And this is very efficient because now if you do not need it, you switch it off. So, you do not generate heat, whereas in previous case transistor is on, you always regulate the power by the input current, input voltage is going to the transistor. In this case it is not, okay. By rapidly turning it on and off, you can regulate the output current and voltage. So, it is very efficient because the cooling it is needed in last case, it is not there. Last case transistor is always operational, it is dissipating whatever you do not want as a heat. In this case we are switching on and off. So, by using a switching transistors, the heat that is generated from the transistor are all reduced, and yeah, we can achieve the very high frequency current as well by using the transistors switching on and off extremely rapidly, and we do not generate much heat because yeah, when you do not need it, when you want to step it down, you can also increase the frequency of switching on and off, right. So, then you can regulate the output very nicely, and then the previous disadvantage of generating heat and cooling requirement is reduced in this case by the use of switching transistors. Yes, it is clear? Yes or no? Any questions? So, what are the system we saw? SCRs, transistors, switching transistors. So, you can see all these three types in regularly. So, okay, so in not so expensive power sources would be operating in one of these modes. SCRs. SCRs is still older. Transistor based power sources are still common. Okay. But the advantage of these guys are, we can regulate to some extent the output. So if you want to have a pulse, you can generate by changing the frequency of turning on and off the transistors. You can play around, isn't it? You can play around the input current, for example, in previous case, so that you also change the output. You can also vary the input which is going to the transistor in such a way that you will also have a pulsing. The output from the transistor can also be pulsed. Same is here. You can also change the frequency of switching on and off. The current can be pulsed. But the disadvantage of having the transformer in the primary input output circuit, it is still there. Until then, until this switching transistor, the power source size is huge, because the transformer, need for transformer is still there, isn't it? So the size of the power source, it is not compact, because the transformer is still there, isn't it? So after serious development in power source technology, people came up with the modern power source, which is the primary rectifier inverter power supply. Okay. So before going to that, so by switching transistor, so we can also change this frequency of switching, and with that we can also have a pulsing with varying current, so IP, and then so this is background TP. Either you can have a high mean or a slightly reduced mean by increasing the switching time, isn't it? And you can also have a shorter switching time and a longer switching on time. So we can also change the average mean current coming out of these the switching transistors by playing around with the time at which you switch off and on. Then your I mean current can be selected. Right? So it is very simple. Transistor, switch on and off, and that will regulate the output mean current. Yes. So as I said, I mean, you still have the need of transformer here. So system is not reducing in size. So the modern development, which led to the compact power sources and with very efficient power sources, is due to the invention of the primary rectifier inverter power supply. Okay. And in this case, so what we do is, the main input current, high voltage and low amperage current, is first rectified. Okay. So first we rectify the AC high voltage, okay, and then low current, which is converted into high voltage DC by using a rectifier, and this can be a silicon controlled rectifier, whatever you can use it. So the AC from the mains converted into high voltage DC, and then subsequently using an inverter, it is again converted into high frequency AC. Okay. So in this case, the system is already becoming very efficient, okay, because we have a primary rectifier which converts the 3 mains input into a single phase high voltage DC, isn't it? And this high voltage DC is converted by the inverter into high frequency AC single phase, and in this case your voltage is already reduced. So you have a high frequency AC with low voltage, and that can be now easily transformed by using a simple very smaller transformer to your secondary system, isn't it? In previous case, the transformer is so big and we play around output. In this case, we play around the input itself, isn't it? So the high voltage, the AC current from the main is rectified into high voltage DC, and subsequently it is converted into high frequency AC with low voltage, and then you can use a simple transformer to transferring from current from these input into the output circuit. And output circuit you can have all these controls, You can have a secondary rectifier to convert back this AC into DC, or you can also send the AC with the required voltage, and then you have all the control electronics, inductors, transistors, whatever you want to have to regulate the output can be used. So, by changing the primary circuits, the components, we can already reduce the size of the power source significantly, because the transformer is not here. The huge transformer you need to convert the high voltage the AC into our power source circuit, isn't it? So, we do not need the need of the big transformer which is needed to convert or to transfer the current from the mains to the power source. So, we use the primary rectifier to change or to convert high voltage AC into high voltage DC, and then do an inverter, it will convert the high voltage DC into high frequency alternating current, and subsequently this can be transformed using a simple transformer small size to your welding circuit. So, advantage of this is we reduce the size of the power source. Power source has become very compact, right. You still have the controls electronics to regulate the outputs. You may have transistors, you may have SCRs. So, all these things would now regulate to step up, step down the currents. But the primary function of converting high voltage low current into low voltage high current system is taken care of by modifying or switching back the positions of rectifiers inverters. It's clear? The circuit looks very simple. So, you will have a primary rectifier from 3-phase main, you will have a single phase high voltage DC, and that is sent to an inverter. So, inverter converts high voltage DC into high frequency AC, and thus can be transferred to our welding circuit, right, using a simple transformer, because it is already in high frequency high current AC. So, you just need to have a simple transformer, very simple transformer to transfer the current, and then you will have a rectifier you may have to convert this AC into DC again, and you will have inductor circuit and then electronic regulation to control the output. So, this is extremely now efficient process, because you do not waste much. So, whatever you are getting 3-phase line, it is all converted. So, the efficiency of the power source increases tremendously using the rectifier, primary rectifier inverter systems. So, the modern power source right now, if you go and buy, you can buy such power source rectifier inverter power source for 5 lakhs, and it will have a power rating of 500 amperes or 500 to 600 amperes easily, yeah, something like this. So, you can carry. Okay. So, if you have a big transformer in the primary circuit, they will be huge. So, recall the picture I showed you in last class in the tape transformer. You need 2% to push. Okay. So, we also have in our laboratories the SCR controlled or transistor controlled power sources. They are still huge, they make a lot of noise. So, now we have taken out by using rectifier inverter systems. So, rectifier inverter would reduce the need of the big transformer, and then we will have a much more compact systems like what you see over here, and you can carry very simply, and you can also regulate all of them, all the functions of regulations are still there using transistors or SCRs. You can use them to achieve the waveforms what you need. You need a pulse waveforms or your square waveforms, or you want square wave DC or square wave AC. So, all of them can be achieved by using the transistors and SCRs in the output circuit, right. It's clear. So, this is state of the art, the primary rectifier inverter systems. So, generally it is fondly known as inverter power sources. Okay. So, inverter power sources are the general terminology we have to use to denote these kind of power sources. So, the moment you say inverter power source is, then the transformer is not there in the primary circuit. Okay, transformer is not there. So, you use rectifier inverter to convert the mains into an high frequency AC and subsequently it is sent to the welding circuit. And then you have a secondary inverter, secondary rectifier. If you want a DC power source, a DC the waveform, and then subsequent control will be there using transistors or SCRs. It's clear, guys? Yes or no? So the major electronic control power sources are SCRs, phase control power sources, and then transistor, switched transistor, and then these guys. So primary rectifier, inverter, power supply. Right, good. So the advancements still are they are happening, because we are always greedy, right? So we'll have to maximize the efficiency of the process, and we also need to control the stability of the process as well. So we also need to make it more adaptive. We have to make it more of we need to modify based on what is happening in real life, in situ. Okay, so the power sources should be made capable of doing these feedback controls. Suppose one example, you are welding within a consumable wire. The moment the consumable makes a short circuiting with the weld pool, and you want to turn the current off. Okay, so then you need to devise a feedback mechanism. Okay, the power source should be capable of measuring voltages. The moment short circuiting happens, and then voltage decrease. The moment it decreases, the power source should identify, okay, so switch off the current. And this would happen extremely rapid pace. Okay, so it is happen with frequency of say for example 100 hertz. So then the power sources, the semiconductors, the electronics what we use to control the output should be regulated so quickly. Unless we have a microprocessor, we cannot do that. So we put microprocessors inside the power source to regulate the complex waveforms what we want to generate. So these rectifier inverter systems nowadays, they are adaptive with the microprocessors inside. So it is like you put a computer inside, okay, with the feedback control. So feedback, the power source get the information from the welding circuit, and then the microprocessor can calculate when to send input. So one transistor turn on because you are sending current, stop. So it should tell the inductors to activate. Okay, so these are all now regulated using a microprocessor based systems. We make life complex, isn't it? So we will introduce the various systems. So transistors to chop a transistor, that means to chop off some of the waveforms, or regulator transistors, or diodes, phase width modulator drives, chopper error amplifiers, series regulators, and then current control, and also feedback to control the wire feed rate. So for a given composition, okay, so the microprocessor should also contain information about the melting rate of the composition. So you choose one composition, then it will immediately the program which is already there, the database, should calculate what will be the ideal wire feed rate for a given current. You set the current 90 amperes, okay, and then immediately the moment you set the current, the power source should identify what feed rate it should give for the wire, isn't it? First it has to make itself comfortable sending 90 amperes of waveform you want. Okay, so then if you also want to control the waveforms during this process, then it will also adapt quickly using a microprocessor, and you do the calculations, and then it will tell, okay, so over there SCR you send so and so current, right? So in this case you have a transistor, so the square waveforms will be sent. Okay, so then the transistors would activate to send the square waveforms instead of conventional waveforms. Similarly, pulsing. Okay, so the switching transistors should be activated such a way that you will have a current pulsing. So these are all controlled by the hybrid systems, right? And then these hybrid systems are all regulated using a microprocessor controlled. Okay, so you will have the various database, ROMs, program ROMs, parameter ROM, Okay, programs is your welding programs, parameters based on the waveforms what you want to generate, and then you will also have a database stored for each compositions, for example, and then they are all regulated using yeah, so power source unit, the wire feed internal, they are all integrated. It is like having in a computer, and it will also be sent out in the input module. So in the front screen, so it all regulated using a microprocessor, and then moment you take the knob and then turn it on, immediately the microprocessor will do the calculations and based on the program what you have, and then parameter what you set, and then you can also have a database of the compositions. For example, I want to weld 1.2 millimeter and ER20 wire, a simple and a USA3 wire, and immediately the microprocessor should arrive at the parameters and database what it should use for given applications, right. So it regulates the waveforms, current voltage waveforms, using that technique and whatever I explained, and the database you give or you develop for a given composition and diameter, for example, right. It's clear. Okay. So I just plug this table from John Norris' book. The use of the conventional power sources, what applications are commonly used. For example, the hybrid power sources, the characteristic of power source, it's fast response, variable output, stable, repeatable, very good efficiency, because again you took the transformer out and you don't need an air cooled, sorry, it's in air cooled systems, because you may still use some of the chopped transistors for chopped applications, and you can automate it, for example. In a conventional process like for a tape transformer, rectifier, moving and variable inductor, magnetic amplifiers, it's fixed design, isn't it? Especially the tape transformer, it can give one output for a switch. So it can be used for welding of a given waveform. Okay. So you'll have an efficiency is not that good. So it's a huge, heavy and industrial duty units. You see this point, what John Norris mentioned. So robust and reliable, because you can it runs. You won't see one diode bursting because there are no diodes. Okay, so in our case, for example, one capacitor goes away in a primary rectifier inverter system, and you'll have to replace the capacitor. That will be close to 1/3 of the cost of the power source itself. Okay. Whereas in a conventional tape transformer, what could go wrong? It will work. Transformer is there, rectifier, that's it. So it will work like a robot. Okay, so it's extremely robust and then reliable, but it cannot be used for complex waveform generation. So it can be simple GMAW, metal arc welding, GATAW, and some simple fabrication purpose you can use. And SCR phase control again, so we can make it electronic regulated. Yeah, efficiency again goes down because of the SCRs we use. Yeah, so it is not really compact compared to the others. And transistor regulator system efficiency is very poor. Why? Because you waste a lot of current. But transistor, based on the operating voltage, it wants, yeah, so you lose a lot of input current. So the efficiency is very poor, and all the power which goes into a transistor, if it is not sent to output, then it is wasted as a heat. So the efficiency is very poor. So we can still use it for high precision jobs, because the output can be regulated extremely nicely by the transistors. Okay, so you will not have a very ripple in the waveforms. So again, the best so far is a primary rectifier systems or hybrid systems. It's in a very compact, and then but it can be electronically complex. Okay, and it is regularly used nowadays for the production purposes, because the waveforms you get, it is to the point. You don't see any ripples in the waveforms or a change in frequencies. If you want some frequency, you can achieve with the use of microprocessor. Yes, it's clear. Any questions so far in the power source? So it's clear, right, how the conventional power source and the electronically rated power source work. So how it has become compact in a rectifier inverter systems, because we are taking transformer out from the primary circuit. So we just have a small transformer to send current voltage from the primary circuit to secondary circuit. Right? Any questions so far?
CMT comes under hybrid.
CMT comes under, yeah, so that's a good question. So if the power source technology itself is a primary rectifier inverter system, but you need a microprocessor control. And also in CMT case you also need synergy. So that means that everything is regulated. Okay. So you need to have a synergy between all these parameters. Okay. So that is again, so what is known as synergy control power sources. In synergy control power source, what do you do? Using a microprocessor control, you have a material database, you know melting rate, for example. So you feed for a given material the welding parameters. Okay, so you know that it is going to melt so and so length for a given time. So you can calculate from that the wire feed rate. Okay, so you suppose if you have a 70 millimeter the arc length, you know how much is going to melt in a given time. So by knowing precisely the melting rate, you can also control the time at which it is going to short circuit. Okay, but then the moment short circuiting happens, the power source should sense whether short circuiting happening or not, isn't it? So that has to come from the feedback, voltage feedback. So the moment the short circuiting happens, obviously there will be the voltage difference. So then the moment short circuiting happens, the power source should turn the current off, otherwise you will have a Lorentzian force generated at the tip. When short circuiting happens, you will have an explosion of the melt pole, then you will have spatter. So that is why we use a synergy control. That means that the wire feed rate, the current, the voltage waveforms, everything is controlled synergistically. Okay. So the box you have, this guy, synergy box. So you set, you cannot set all the parameters independently. You set a current, so obviously everything is taken care of for a given composition. You cannot independently vary. If you want to achieve a metal transfer by short circuiting. Okay, so if you want to independently vary, then you cannot use synergy. So then you will have to play around each and every parameter to optimize it. So that is how now the power sources, modern power sources they do, because they already have this energy developed in the database. Yes, it's clear? Okay, so I don't want to go in much detail because it's too much for you to handle. So as of now, we need to know the types of power sources. When you open the box, you should identify, you should get yourself comfortable. So what sort of power source you are welding with. Yes, it's clear? Okay, good. So any questions in power source? So I already gave an analogy, right? So it is same as any system which are electronic regulated, computer for example. So you also regulate the current and voltage. And the motherboards will have all these parts. The purpose is different. Okay, so the output is like low voltage means you need to reduce from the high voltage, high current into low voltage, low current. And USB point, for example. So you may have such a system. That's what you call it as a board, right? Same as here, no difference. So how efficient you make that is important.